Hello pre-calculus students, and welcome to our second video in our series on probabilities here. And just a couple note and really somewhat of an apology if you're in Mr. Wen's class because there's a couple typos in here. So maybe I corrected it already in your paper, but if not, please correct them now. Of rolling a probabilities of the sum of rolling two dice. In other words, we're not interested in the actual individual pieces. We're looking at the probabilities of rolling a sum. Okay. Same thing here. We're interested here in the probabilities of rolling a sum of 11 and then a sum of 12. Okay, so these are typos. So make sure you please correct that in your notes before we move further, because otherwise we're going to be dealing with a different problem. Okay. So now let's look at this issue of the probabilities of rolling, of the sum of rolling two dice. So let's look at, this is example 3, sum of two dice after we roll it. After roll. Well, what are the possible sums? In other words, what is our sample space? Well, if you take two dice and you roll them, the dice are numbered from 1 to 6, so the sum can never be less than 2. Right? The smallest sum you can get is 2. So those are called snake eyes, right? For those of you who are in the business. All right. So then you can get a 3, you can get a 4, 5, 6, or 7, and 8, and 9, 10, 11, or 12. Okay, and 12 is like getting two 6s. And so there is really nothing else if we're talking about the sum. And that's why I emphasize this. Now, if you look at these two sample spaces, it's like these two sample spaces are actually equivalent in some sense. Okay, let me see if I can arrange these boards so you can see. Okay. Whoops. Okay, this sample space here with the sums, okay, and this sample space that I had down here where we list all the possibilities, they're really the same sample space. But it's the difference is that we organize these differently. We just look at the sums. So in other words, all of the numbers that add, all of the possibilities that add up to 2 are captured in here. All of the possibilities that add up to 3, in other words, this here adds up to 3. This also adds up to 3. So these two events are captured in this single number here because this is the sum of these two dice. Okay. So let's see now what, if we consider this scenario, what's the probability of rolling a 1? Well, I'm sorry, rolling a 2. 1's not in the sample space, so that would be 0. Rolling a 2, well, you can roll a 1 and a 1. So this is 1 out of 36. What's the probability of rolling a 3? Well, we just talked about that. You could roll a 1 and a 2, or you could roll a 2 and a 1. So there's two ways to do that, 2 over 36 or 1 over 18. Okay. Let's keep going. Probability of rolling a 4. Okay, so this is a little bit more work to think about here. So you could roll a 3 and a 1. You could roll a 1 and a 3. Let me use a different mark here. I'll use the box here. Okay. Or you could roll a 2 and a 2. So there are 1, 2, 3 different ways to do this. And you can see how there really is a link between the two sample spaces. So 3 over 36 equals 1 over 12. And I'm going to write down these extra examples, and I will leave you to solve them. What you really need to do right now is hit pause and figure this out for yourself, and then hit play again and compare it to my answers. So go ahead, hit pause, fill in these probabilities, and then you should hit play again and compare this to my answers, and just really try to convince yourself of your solutions. Okay, hopefully you were honest with yourself and you actually try to do this on your own. And you can see my answers here written in red, and I've also simplified this whenever it applies. Okay, and so what we can look at here is, let's just take the sum of all of these. So let's say if we added all of these up. So if I added probability of 2 plus probability of 3 plus all the way up to probability of 12, okay, what would you get? So you should hit pause, add these up, and then let's see the results. Hopefully, it's not too much of a surprise that the answer is in fact 1, okay, if you actually added up all of these numbers, okay? And so this brings me back to my next point about the probability of functions. And so let me define something else that isn't quite in your worksheet, the notes of your worksheet, is the word disjoint. Okay? Disjoint means non-overlapping. For example, the probability of getting a sum of 2 and the probability of getting a sum of 3, those two events, getting a sum of 2, getting a sum of 3, those are disjoint because you cannot get both a sum of 2 and a sum of 3. However, the probability, or sorry, the event of getting a 4, okay, getting a 4 and getting a sum of 5, those are not disjoint, because if you get a 4 and a 1, you got a 4 and you also got a sum of 5. So those are not disjoint. Okay. So let's make an important note here. We're all taking notes, but this is an important note, or a little bit more important than the rest. So if E1, E2, E all the way up to E to the N are events, are all disjoint events that form the sample space, then the probability of E1 plus probability of E2 plus ... all of these probabilities should be equal to 1. In other words, the probability of all the disjoint events in the sample space added up all together, they have to be equal to 1. Okay? And it's not just that all the disjoint events, it's that the sample space is made up of all the disjoint events. Then when you add them together, they add up to exactly 1. Okay, so with that in mind, we're going to move on to our next sort of major important concept here, which is the probability of something happening and then something else happening. Okay, so let's look at this problem. The probability of rolling 2 dice twice and getting a sum of 11, then a sum of 12. Okay. And so some of the things for us to consider here. Now I know if you've seen this before, you've seen this in another class, you'll see, well, either I add the 2 or I multiply the 2. And if I pick one of them, I'll be correct about half the time. But again, that's a poor strategy to go about this because you're not going to get very far. And in fact, as we get to the difficult problems, that strategy is going to fail you. So let's think about what our sample space is here. Because what I'm doing here is we're taking 2 dice, rolling them, picking them back up, rolling them again. Okay? So let's look at that first roll. Okay, so in the first roll, we could get a 1 and a 2, a 1 and a 1, a 1 and a 2, a 1 and a 3, a 1 and a 4, so on. And then you can get a 2 and a 1, a 2 and a 2, so on. Okay? And you can keep going like this until you get 36 different possibilities, 6 and a 6. Again, these are 36 different possibilities, okay? So in other words, that first roll, there are 36 branches to this tree. Six possibilities. So that's the first roll. Then you have to roll it a second time. So the second time you could roll a 1 and a 1 and then 1 and a 1 again, 1 and a 2, 1 and a 3, so on, and you get 36 of these branches until you get to 6 and a 6. Okay, so each one of these branches is going to split up that way. So this is another 36 possibilities. So in other words, the sample space has 36 times 36 outcomes. Okay. So we know that then our denominator is going to be 36 times 36. Now, how many of these result in a sum of 11 and then a sum of 12? Well, how do we get a sum of 11? On the first roll, well, there's only one way to get it. We have to hit actually two ways to get it. We have to hit a 5 and a 6, or a 6 and a 5. Okay. And then to satisfy the second requirement of getting a sum of 12, you have to hit a 5 and a 6 on the first roll, and then a 6 and a 6 on the second roll. A 6 and a 5 in the first roll, or a 6 and a 6 on the second roll. So altogether, there are 2 different branches that get you to this point. Okay. And both of those deliver a result of an 11 followed by a 12. Okay. And so we can also split it up this way as 2 over 36. That's because in the first roll there are 2 possibilities, times 1 over 36, because for each of the first rolls, there's only one way for you to get a 12 on the second roll. Okay? So this is the probability of 11 times the probability of 12. Okay? And rather than do an example where we have to add, I like you to think of that example and ask your teacher in class to explain it a little bit further. I'm going to do one more example here that's related to this. So I'm going to say, what's the probability of getting an 11, then a 10. Okay. So in other words, we've got to change this problem just a little bit. I can get an 11 here. But on my second roll, I don't want a 12 anymore. I want a 10. So I can get a 5 and a 6, and then a 4 and a 6, 6 and a 4, or a 5 and a 5. 4 and a 6, 6 and a 4, or a 5, or a 5 and a 5. Okay, so I could get an 11 by rolling a 5 and a 6, and then for each of those, there's 3 ways of doing this. So on the first roll, there's still 2 over 36 ways, because that's the possibilities of getting an 11. And then for each of those, there are 3 ways of getting this. Okay. So in other words, this is 6 over 36 times 36, which is 1 over 216. Okay, so some of the concepts here that you should think about is that really some of the sample spaces, they look different, but they're really the same because some of the outcomes are sort of collapsed together into other events. And then to think carefully when we talk about scenarios when you have to roll to roll a number and then roll another number, we multiply them because of this branch. And we haven't seen an example where we have to add them yet, but we will soon see it later. You should really look back and think of a way, what scenario would it be where you have to add something. And again, hopefully you took a lot of notes on this, not just on what's being written down here, but what I'm saying and what thoughts and ideas that come to you as you're going through this. This is really a deep thinking type of lesson, not so much something that has to be written a whole lot. Okay, keep working at this. As always, ask for help. Have a wonderful day.